Okay, folks, we've just opened things up. So as you're getting comfortable in here, let me just say a few words of hello and welcome. Good afternoon, everybody. On behalf of ForSpace, welcome in for this afternoon's event, Sustainability on Land and in the Water, whereby you'll hear from 3 panelists today who will present their work on protected areas, community gardens, and remote detection of water pollution in turn. And then we'll open it up for your questions. This event is, of course, part of a week-long series of events on sustainability and the climate crisis, brought to you by the Loyola College for Diversity and Sustainability and the Loyola Sustainability Research Center in collaboration with ForSpace. What is ForSpace? Those of you who aren't familiar with us, Concordia University's ForSpace is located in downtown Tiohtià:ke, Montreal, on unceded Indigenous land. We are a physical space on campus. We operate as the kind of front door to the university, if you will, whereby we invite you in to experience any number of interactive live events on a given day or week, and at the same time engage with research initiatives and course activities brewing across Concordia. We invite you to check out our schedule of events by going to concordia.ca/4. Those of you wanting to share this talk with your friends and colleagues, you're in luck. We are currently recording and live streaming at CU ForSpace on Facebook, so I'll pop those links in the chat momentarily. You're more than welcome to join in the conversation today by sharing thoughts and comments in the chat. It's been activated for you exactly for that reason. But if you have burning questions for the panelists here today, we invite you to engage with them in one of 2 ways, either using the Q&A box. If you're a texter, if you rather spell out or write out your question, please put it in the Q&A. Or if you prefer to speak, no problem, just raise your virtual hand and we'll come in and assist you, unmute you so that you can speak your questions out loud. Okay, on that note, it's my pleasure to pass proceedings over to the mastermind behind this week of activities, Rebecca Titler. Over to you.
Hi, everybody. Thank you so much, Anna, and thank you to the whole team at ForSpace, to Doug and Anna for hosting us today and all this week. We have had an exciting series of discussions so far, and we're only halfway through, so we have the rest of the week to go. Thank you for joining us for this panel today. As Anna mentioned, we are coming to you live from Tiohtià:ke today, which is unceded land of the Ganangkahäga of the Haudenosaunee Confederacy. Tiohtià:ke means where the 2 part ways, and this is a reference to the 2 communities of Kagnawake and Kanesatake that are still present to this day in the area, despite the genocidal actions suffered by them and by many Indigenous peoples around the world at the hands of settlers. Tiohtià:ke remains a meeting place for those of many nations and viewpoints, and we will be discussing some viewpoints, various viewpoints today and throughout the week. So thank you for being here. And with that, I would like to welcome everyone on behalf of the Loyola College for Diversity and Sustainability and the Loyola Sustainability Research Center. We do have a Sustainability Across Disciplines conference, usually in person every year. This year being online, we have decided to do a series of discussions instead and have it be a little bit more interactive for the online environment. We will be starting today with Clara Freeman-Cole, who is doing a master's degree in the Department of Geography, Planning and Environment here at Concordia. Clara is working under the supervision of Professor Jochen Jäger here, and she will be speaking to us about the work that she's doing for her thesis. Go right ahead, Clara.
Cool. Hi, everyone. Let me just share my screen. Is this the right screen? Can everyone see? Cool. So hi, everyone. Today I'm going to talk to you a little bit about my research, which is landscape fragmentation in Canadian national parks. I'm going to show you some preliminary results from Kootenay National Park, and I'm also going to discuss why you shouldn't feed French fries to a grizzly bear. So to outline the main concept, which should change now. There we go. Landscape fragmentation refers to the breaking apart of a habitat, ecosystem, or land use type into smaller pieces, which has been increasing at a rapid pace in many parts of Canada. This is mostly resulting from conversion and development of sites into settlements or other intensively used areas. It affects wildlife habitats, ecosystem processes, and services. The exact rate at which development has been dissecting Canadian landscapes is unknown. So this study measures the fragmentation of national parks at key time steps throughout their history, including before their designation and up to the present day. In conjunction with the goal of leaving Canadian national parks unimpaired for future generations, the concept of maintaining ecological integrity as a management standard has emerged since the Parks Policy of 1994. Parks Canada states that an ecosystem has ecological integrity when it has the living and non-living pieces expected in its natural region, and B, its ecosystem processes occur with the frequency and intensity expected in its natural region. Therefore, the aim of parks is to allow people to enjoy national parks without damaging their ecological integrity by maintaining or restoring the expected genes, species, and communities of a region. Stresses on national parks stemming from fragmentation include changes in land cover, the subsequent changes in local climate, the modifications of watercourses, and disruption to various other ecological processes. And also, as well as roads and railroads acting as barriers to animal movement and reducing the amount of habitat available to them and associated connectivity for just general terrestrial mammals, there is also an enhanced species mortality risk due to vehicle collisions. So, underlying all of the above, the main risk to maintaining ecological integrity in parks is the overuse of national parks and their surrounding areas by humans. NGOs have noticed that recently there has been an increased focus on tourism, non-nature focused recreational activities, and revenue generation in the Canadian National Park system, as you can see here, and just a general lack of attention to the effect that these might have on parks' ecological integrity. So just to go over a quick history of Canadian national parks, there's been 135 years of Canadian national park history, and in general there's been huge changes in the landscape management approaches of these protected areas. There's been a dramatic shift from tourism and the exploitation of resources to the acknowledgement of biodiversity, habitat restoration, and eventually ecological integrity has been significant. However, historically, national parks policy in terms of both designation and management has been mostly centrist in its origins and its applications, which, giving consideration to both the economic benefits of tourism and resource extraction and conserving wildlife. The general running theme of heavy anthropogenic pressures on parks, even despite these preservation-focused and ecological integrity-focused policies, demonstrates that it's essential to keep monitoring ecological integrities, such as ecological indicators, such as fragmentation, over various time steps in order to maintain and expand the national park system sustainably. So yeah, in my study, human elements are compared over time from designation to present, and the fragmentation of the landscape resulting from these is calculated using the effective mesh size metric. This is a measure of fragmentation that expresses an area, given the probability that 2 points chosen randomly in a region are connected. And overall, the smaller the effective mesh size, the more fragmented a landscape is. The effective mesh size has a number of advantages for this work, including being suitable for comparing the fragmentation of regions of varying total areas, such as national parks, like for example, Banff National Park is much bigger than Rouge Urban National Park, for example. And it also describes the structure of the barrier network in an ecologically meaningful way. And yeah, I also use a before-after control impact, or BACI, study design to evaluate the fragmentation of a site by comparing the changes of the fragmenting elements before and at various times after the designation of the area as a national park. So BACI designs such as this have a very high inferential strength, particularly where an environmental variable has changed, in this case fragmentation, between the control sites and the impact sites. This gives strong evidence that it is the park designation that has caused the observed change in the landscape. So, in order to map temporal changes in landscape fragmentation, older data sets have come in the format of hard copy maps, and so a digitization method is required. These maps are being scanned and georeferenced using consistent topological markers such as rivers or mountains, and then digitized to a vector layer using the same element identifiers as the current data. So just quickly, I want to give a shout out here to my team of GIS volunteers, Natika, Julia, Kyle, and Zach, who have been helping me with digitizing, deciphering the old maps and learning about creating vectors from scan maps as they go. So yeah, it's been super helpful. So now I'll just quickly give a quick example of some preliminary results from Kootenay National Park. The history of this park is particularly interesting, given that it was established as part of an agreement to build a new highway across the Rockies, a major fragmenting element in the landscape. Construction from the Columbia Valley began in 1911, but it was halted by World War I. By 1919, the province didn't have the necessary finances to finish the work, and so it was decided that the federal government would build the Banff-Windermere Highway in exchange for 5 miles on either side of the road for a national park. So today, Kootenay is part of the wider mountain parks region, which attracts more visitors than any other park area in the country. Also, if you see on the slide, the link for the bear picture is for a story where a motorist was fined for feeding French fries to a grizzly bear. And this demonstrates how elements such as roads will increase negative wildlife-human interactions, such as feeding wildlife human food. So in this case, once bears get accustomed to eating human food, they are more likely to search it out in the future. And this puts humans in the park at more risk, and also puts the bear at more risk from being put down for general safety. So yeah, back to the digitization. As shown here, the human elements in the park were compared over time using data from 1926, just 6 years after the park establishment, 1974, which was just after the national wildlife preservation movements of the 1960s, and today. These maps are from the Department of the Interior and the Surveys and Mapping branch of Mines and Technical Surveys, and they cover an area of the national park and the surrounding landscape. In comparison, the current data can easily be downloaded as open source GIS vector data for like all roads, waterways, settlements, and so on. The park was split into landscape patches for each timestamp. And a patch means an area where there are no fragmenting barriers, as shown here. So each color with a black boundary demonstrates a landscape patch. And as you can see, there's a clear barrier where the highway is like through the middle. Then the effective mesh size, the metric of fragmentation, was calculated. So as you can see in this graph, the effective mesh size of Kootenay National Park has decreased over time. And this indicates that there's been increasing landscape fragmentation in the park. And this is mainly due to the establishment of more trails and unpaved roads in the area. And although these results are somewhat expected as Canada's tourism industry has grown and infrastructure has expanded, it's not very meaningful until it's been compared to an unprotected area. Therefore, once the national parks have been digitized, the unprotected control areas will be next. So here for Kootenay Park, this will be directly south, and it's for an area of similar size and overall original land use, which is kind of near the towns of Cranbrook and Fernie. So yeah, to continue this study, the effective mesh size will be calculated for the rest of the national park system from near to designation to current day. And alongside this, the unprotected control areas of historically similar landscape configuration will be analysed to enable a comparison between the parks and the unregulated landscapes. Explicit monitoring and reporting on the degree of fragmentation is essential for identifying any changes in trends and evaluating compliance with land use and monitoring legislation. Sorry. And so this work intends to contribute to conservation actions that are required across protected areas and Canada in general, to improve landscape connectivity for species and to sustainably manage landscapes so that the country's rich biodiversity has enough habitat to maintain itself. So yeah, thank you for listening to my presentation, and that is my research that I'm currently working on.
Thank you so much, Clara. Does anybody have any quick questions before we move on? We will have points of clarification after each presentation, and then we will have a longer discussion at the end of the 3 presentations. If nobody has a question, quickly, I do. Clara, I know that you're aware undoubtedly of all of the literature indicating that fragmentation is actually really not very important in terms of a predictor of biodiversity loss. So I was wondering why in this particular case you found it important to focus on fragmentation.
I found in this particular case, particularly because of the mountain parks, there is a lot of increasing kind of human activities in the region. So currently I'm thinking about like an example recently where in Banff National Park, there's the railway that goes straight through it. And a lot of the wolves have been like kind of killed on that rail line because the Bow Valley in Banff National Park is a very it's a connectivity corridor, so there's a very high movement of animals through that area. And so things like that, like kind of an area where national parks are supposed to be areas where biodiversity is supposed to thrive and animals are supposed to be able to move with like freely throughout. And at the moment, because of increasing like A, tourism, and B, general building in the area, it's really kind of becoming difficult for animals to move about and like use the habitat as they naturally would. So yeah, it's something that Parks Canada does very kind of monitor, but not across the whole park system. So that's why I thought it would be interesting to kind of compare between all the different parks and compare how this has kind of changed in areas that have also not been protected. So yeah.
Yeah, so it's a particular problem with the roads as opposed to with fragmentation per se.
Yeah, mostly kind of linear infrastructure, like fragmentation kind of stemming from human activities, which things like towns, I guess, animals can move around them, but they're still quite a fragmenting kind of blob, I guess, on the landscape. But it is mostly the linear infrastructure that kind of blocks animals from moving how they naturally would.
Right.
So, yeah.
Thank you so much. With that, if anybody has any further questions for Clara, you can save them for the end, but we need to move on. Oh, Jacques, did you have a quick one? Go ahead.
Yeah, well, I was just wondering if there was, if you found, if there was a species that was more impacted by the fragmentation, or if you have a theory of a species that could be more impacted.
I think just really because I'm studying the whole national park system, it really depends on the park. But most parks have an umbrella species. So for example, in Banff, this can be bison and bears, like the large terrestrial mammals. And in Elk Island, it's very much bison. So yeah, the problem is like once fragmentation kind of blocks the movement of these animals, it kind of causes a knock-on effect to the rest of the species in the ecosystem, if that makes sense.
Oh yeah, that makes sense. Thank you.
Thank you, Clara. I'd like to welcome our next speaker, who is Sahar Ali Nashad, who will be talking to us about some of the work that she is doing for her PhD in the Department of Geography, Planning and Environment here at Concordia under the supervision of Professor Silvano de la Llata. And this is a little bit of a switch because Sahar's work is on community gardens. So Sahar, I will invite you to share your screen and take the stage.
Thank you so much. Hi, everyone. So today I'll be sharing with you the presentation I pre-recorded for today's talk. And yeah. Collective gardens and neighborhood social sustainability in the time of the pandemic. This research considers collective gardens as emerging public and common places that foster sociability. Gardens as outdoor public spaces are becoming popular in the neighborhoods, especially in the time of COVID-19. This research tackles the mode of management that govern third places and examines its effect on social inclusion and diversity. As third places are historically managed either publicly or privately, this research argues that using self-management governance mechanisms facilitates social inclusion and diversity in third places and promotes community building. Moreover, during physical distancing imposed by the pandemic, outdoor third places can frame neighborhood dynamics by favoring social interactions. Rapid urbanization has given rise to a loss of community and sense of place, and is associated with increasing levels of anxiety and loneliness, while third places contribute to health and well-being of individuals and communities. While loneliness is a widespread problem of urban centers, the COVID-19 pandemic has brought this issue to the fore. The reinforcements of physical distancing, isolation, and stay-at-home orders have intensified the existing modern life problem of solitude. During the pandemic, there is greater recognition of the need for access to community hubs within a walking distance in our neighborhoods in order to lessen the health risks of taking public transport. To combat the detrimental social effects of physical distancing, people are gravitating to open urban spaces. Public places are being used for social gatherings now more than ever. These outdoor living rooms of the neighborhoods playing a significant role in the COVID-19 pandemic experience. This research explores the governance dimensions that underpin the construction of place and community through the lenses of third places. It seeks to examine the connection between horizontal or autonomous mode of management in third places, where residents provide direct input with their active engagement while benefiting from social inclusion. In terms of the research questions, looking at the social interaction opportunities, does Badimanset Collective Garden provide interaction opportunities? Does it encourage collective actions? Does it contribute to community building and neighborhood social cohesion? In terms of non-commercial engagement in the garden, does the absence of monetary transaction contribute to increased participation? Does the not-for-profit feature of collective gardens lead to mobilization of tangible and intangible resources? And in terms of facilitating different groups' participation, what are the potentials for cultural exchanges via collective gardening? Do collective gardens as outdoor third places provide a prototypical social platform for different groups? Having a qualitative approach in this research, the fieldwork consists of two methods: semi-structured interviews and observational fieldwork. The interviews are used to gather information such as the challenges in this mode of management, as well as the strategies employed to include different groups. Moreover, garden participants are being interviewed on their experience of participating in decision-making practices at garden above and beyond their experience of engagement in the garden activities. Observational field notes are written immediately following each visit to Badimanset community space. Badimanset was a heritage industrial building remodeled into an accessible meeting place in the Point Central's neighborhood. As a collective property, Badimanset aims to create a hub of services. It creates an ecosystem based on experimentation and learning. It promotes self-reliance, interdependence, and resource sharing, and is practicing a horizontal and democratic mode of management. The spaces surrounding Badimanset are all places that have been used creatively by the community. The transitional installations reflect the desires of the participants. Even in terms of social distancing, small teams continue to plan and develop outdoor projects. The first phase of the farmhouse took place last spring as an inspiring example of the collective project. La Fragmentation is a neighborhood initiative supported by several local groups: Club Populaire, Action Gardienne, Le Detour, which is the grocery store, and also Badimanset. Its approach is in favor of food self-sufficiency in the neighborhood, based on the defense of everyone's right to healthy food. There is a greenhouse, there are containers as food microbiology laboratories, there is a chicken coop, and the gardens for growing vegetables, which also has a medical plant section. Badimanset Collective Garden has boxes in front of the building and also all along the side of the building. There are gardening sections towards the back of the building. A garden committee consisting of volunteers meets regularly to discuss garden-related issues. Based on the participation observation and also the interviews, in terms of social interaction opportunities, people report that they have more time during the pandemic to help in the garden for planting, watering, seedling, harvesting, etc. Kids come to the garden with their parents to check the chickens. Kids have the opportunity to play in the sandbox while their parents are gardening. Due to the closure of the building to the public, people use the outside area more often. They hang out with friends in the garden while respecting the safety measures. They have time to explore their own neighborhood. In terms of non-commercial engagement in the garden, according to Glover, community gardens are venues for resource mobilization. In this case, people are using the gardening tools in the site, and occasionally they share their culinary knowledge with each other. Volunteers can take vegetables for their effort in the garden, and citizens who are not involved with the gardening can pay like $1 for a small basket of vegetables that gardeners already picked and put on a shelf at the garden. There is no supervision for the payment, and it's all based on trust. In terms of different groups' participation, finding ways to embrace diversity is an important societal concern, especially in a multicultural city like Montreal. Building on Glover, community gardens as third places and neighborhoods provide the platform to increase positive contact between members of different groups. There were barbecue nights with people from the neighborhood. As there's a grill in the fragment, people would use some vegetables that they already picked from the garden, or they would bring their meal to prepare in the garden and eat with each other. There were music nights organized by Santa Ben, which is a bar at Bâtiment Set also. At the end of the summer, there was a harvest festival that people were invited to help with the harvesting, which was followed by a barbecue party. La Fragment committee also presented their projects in terms of the future of the Fragment, and citizens were encouraged to provide their input in terms of what they desire to have in the garden. This research demonstrates the value of recreating and reclaiming third places in the contemporary urban context, as neutral venues, third places provide opportunities for people to meet, interact, and develop a sense of community, particularly in time of crisis. Hence, drawing on the preliminary analysis, collective gardens, which favor a wide array of non-hierarchical social interactions based on not-for-profit exchanges, provide potential low-key platforms for the informal social gatherings of individuals at the neighborhood scale. Although ensuring the diversity and inclusion is a challenge which requires continuous effort for encouraging the interested individuals to stay involved in the collective actions. This pandemic underscores the critical role of third places as community anchors. As COVID-19 pandemic requires us to practice physical distancing, it also encourages us to better manage and use the public places as spaces for interaction for thriving communities. Thank you.
Thank you so much, Sahar. I have a question already in the chat, which is a question of clarification, which is, what is horizontal management? Can you explain that for us? Maybe you can stop sharing your screen so we can see you.
Yes.
I'll give you a second. There we go. So the question from Marikid Mayeno is, what is horizontal management? Marikid, I'm so sorry if I messed up the pronunciation of your name.
Horizontal mode of management is when we don't have any hierarchy. There is no position that is above the others who will let the others what to do. As people together, they form a committee, and then they all have the same power to talk about their ideas, and then they decide together, collectively. And this is a way that members from the community, they feel empowered that they have a say for making decisions for the community space.
Great, thank you so much. Does anybody have a quick follow-up question or a quick other question of clarification? If not, we will move on to Jacques' presentation. And if you have any questions for Sahar in the meantime, you can pop them into the Q&A, and we will hopefully have time for them after Jacques' presentation. So in the meantime, I would like to introduce Jacques Simon-Mayer, who was actually graduated from Concordia. Now he was scheduled to present last year at our in-person conference when he was completing his honors research. And he is now working as an environmental consultant in the area of water management and potable water. And he will be talking today about the work that he did with Angela Cross for his master's, for his honors degree here at Concordia in the Department of Geography, Planning and Environment. Go right ahead, Jacques.
Yes, thank you. Just give me a second. I'm sorry. Here we go. So as she was saying, this is my project is on the mapping and monitoring of surface water chlorophyll. This is using satellite imagery, and this project was done Professor Angela Cross. So, and first I want to define the eutrophication. First of all, I'm talking about eutrophication because it has, when there's a lot of chlorophyll in the water, eutrophication happens. This is why I'm monitoring chlorophyll exactly. And eutrophication itself is a bloom of some bacteria and or algae. And this happens because there's an excess amount of nutrient that is poured into the water body. And this can be caused by sewage that dumps in the water, or it can, and usually it's because of runoff from agricultural lands. And the algae produced may produce harmful toxins. For example, Lake Erie, they have a toxic algae. And in 2014, there was a notable event that happened where the algae population, there was a viral outbreak inside the algae population, which caused their cells to burst, and they released a lot of toxins in the water, which made its way in the water system of the neighboring town of Toledo. And this made 500,000 people not have access to water, but it's not just a boiling water advisory, it's just you cannot use the water for anything. Eutrophication is harmful to the ecosystem, not only because of the toxins, also simply put, when there's a lot of regular algae, after a while, there's low oxygen levels in the water, which has cascading effects on the ecosystem. To monitor this, conventionally, we do field sampling, analyzed in the lab. This is costly, doesn't really show the whole spatial pattern, and it's pretty hard when you have a large water body. To overcome this, we want to try to use remote sensing or satellite imagery. So to be able to analyze water in the water using satellites, we need to understand that the satellite records the information that's light that's reflected off the ground, and that light contains information about what exactly is on the ground. To identify what's on the ground, we use something called spectral signatures. And a spectral signature, plainly put, it's a fingerprint, a light fingerprint of individual objects or molecules. And this is a conventional one. So you have on the x-axis, you have the wavelength, and you have the reflectance, and you see how it reflects light at different wavelengths. If you have a red shirt, you're going to see a huge peak in the red area of the electromagnetic spectrum, because we see red because the dye inside the red shirt reflects a lot of red light. So first, this is the study area. This is in the western area of Lake Erie. I was talk about the research questions. First of all, want to know how viable is a satellite planetscope for coal-fair quantification. It's a new satellite, has very high resolution. You can look at fine details, and it has a daily overpass. We can have a daily image of the study site. Also, want to evaluate the effect of those spin solids on the model, and if it has, or find a workaround. Also, want to try to use this information to identify which areas around Lake Erie contribute to algae blooms. So I'm going to go through the methods. So first of all, we have in situ chlorophyll data that's sampled weekly by NOAA. It's the US, it's the North, it's Oceanic and Atmospheric Studies. And I have the satellite response, which has a daily overpass. I correlate those two and create a model. From this, I can have a chlorophyll maps. I also obtain a land use map, and I obtain a digital elevation model. And from the digital elevation model, I did a watershed analysis from which I could see the stream networks and the basins, so I can see where the water pours into Lake Erie. Using all this information, I want to see if I can find a way to identify polluting areas. So first, to create the model, we want to find light bands where we can distinguish different concentration of chlorophyll. And what we ended up using is a spectral index. We created a spectral index using the near infrared and the green region for chlorophyll. So let's take a break from this. To simply put, the logical reasoning how we did this, as an analogy, if you're trying to make a red velvet cupcakes or red velvet cake, you're gonna have a batter which is darker color. And as you add more of red food coloring inside your inside your batter, cake batter, is going to become more and more red. As you increase the concentration of your food coloring, the intensity of red increases. And you can readily identify this with your eyes, and you can essentially analyze the concentration of red food coloring just by looking at the color. So this is essentially what we're doing. In the near infrared region, those are 4 different concentration of chlorophyll. There's a good difference between the different concentration, and also the same thing in the green region. So we can use these to be able to quantify the chlorophyll in the water using a satellite, to train the satellite to be able to identify it. And if you look, for example, the blue region, you don't really see what's going on. It's not really useful for us. First, we correlated the spectral index with chlorophyll with using ordinary least regression. we evaluated the total suspended solids accuracy. It reduced the model's performance, as you can see here. On the left side, you have all the data where a lot of the data has a lot of suspended solids in terms of percentage relative to chlorophyll. And on the right, we use the data only from the months of July and August, which had total suspended solids concentration less than 30%. And you can see if you look at the R squared, there's a big increase. This, logically speaking, is because the spectral signature of suspended solids in the water is very similar to the spectral signature to chlorophyll. So they have similar fingerprints. This is why. But this this is one drawback of the model. We use it only for the months of July and August. But however, those are months that are very important for eutrophication to monitor. So using this, we have the finalized model. This is the chlorophyll we're looking for, and this we put the satellite response of green and near infrared. The R squared is 0.93. It's higher than before because we put another restriction on the model where we evaluated that anything below a concentration of 8 ppb, the satellite cannot readily identify what's there. So our lower limit is of 8 ppb of concentration. So it's only applicable for the months of July and August if we use this specific and not generalized model. And the average error is of 21.7%, which is good for a remote sensing project, but it's not quite to the level of institutional or research ground laboratory. But it's still good because it's comparable to environmental private laboratories, which usually have average error of average precision acceptable of 20%. And we have a relative root mean squared error of 12.2%, which is also relatively good. So now we're gonna go through, I'm just gonna focus on this area, just to give an idea of worst case scenario. So those are 4 drainage basins where they pour into those dots. There's 4 of them. And here is the applied model here. You can see the orange is crops and the red is urban land use, if you want to get an idea of where we are. The light blue is outside detection range. It's too low for us to detect. The blue is water that's relatively good in water quality relative to eutrophication. Green, eutrophic, it's problematic. Dark green, hyper-eutrophic, very problematic. And then you have the dark, which is over our upper limit. So it's a high value, but we cannot accurately say what the value is, but it's a high value of eutrophication. So this, I want to see what happens 11 days later. So this is the model applied 11 days later, and we see that eutrophication becomes massive. And looking at the pattern, it seems to be coming from this river, which is part of this huge watershed that contributes nutrients and chemicals that might promote the growth of algae. Something interesting here too, we have here on this side, this small watershed that you see on this side. There seems to be an accumulation here that is not related to this. And this is interesting. My first reasoning is that it could be this watershed that influences this one, or there could be a sewage system. So I went through the cities of Toledo's water system, and there's no sewage system coming out here. However, there's actually a water intake for the water, for potable water for the residents. So this makes this water resource vulnerable for the residents because this is where they're taking the water from, and there seem to be a lot of promotion of algae. Another interesting thing, not related and I don't think it would affect eutrophication, but in this area, in the same watershed that is connected to this water intake for the potable water, there's a lot of gas extraction wells. So 2 problems already there for this makes that water resource vulnerable. So why is this research significant? First, we can get continuous high resolution monitoring of eutrophication of Western Lake Erie, so we can see in advance what's going on. Also, it can help us identify non-point pollution sources, as we saw. This was not the focus on this project, but we wanted to see if it could be used as an extra tool to be able to find maybe the culprits or where it comes from or areas that are problematic. And also, future research should improve the model with more data points. This will make the model more reliable and also improve it. Thank you for your time. Thank you for having me. And if you have any questions, feel free to ask me or any suggestion. Thank you.
Thank you so much, Jacques. Does anybody have any questions for Jacques? I do.
Yeah, I have a quick question.
Yes.
Sorry if I missed it in your presentation. I was wondering what satellite imagery you used and why.
So I used PlanetScope. I briefly mentioned it. It's relatively new. I use it for two reasons. Well, first of all, it's not really in the literature yet. They didn't use this for chlorophyll quantification, the satellite. So I wanted to see the viability of the satellite. Second reason, this has potential because it has very high resolution. So this means that we could look at small streams. And like, for example, you could look at small streams that change in chlorophyll, right? So you can maybe see in an area, you could see an area, okay, well, this outlet here that this industry is discharging, and this seems to be an increase in chlorophyll in this area. So those are finer details that we can look to maybe pick where the pollution might come from. This is one of the biggest advantages of this satellite. It's also, it has daily images. This makes it useful too.
Okay, cool. That's super interesting. Thanks.
Yeah, thank you.
I have a question. I was surprised to see such a big change so quickly. Is that because of the increasing temperature in the summer, or how do you explain such rapid changes?
I assume that too. I assume that the temperature has an effect. We need to keep in mind Lake Erie. They didn't choose Lake Erie just randomly. It has a big eutrophication problem. It has a lot of inlets of, and you can see the huge watershed that you could see that had a lot of crop land use and urban land use. This is probably all fitting into this river, and I assume also with the dramatic increase in temperature, and they have all the food that they want, all the chlorophyll, the food that the algae, they have all the food that they want. They just reproduce all at once. And this, I chose those images too because I revalidated with ground data. So this is really what happened. And they also saw in the comments, they saw sludge and even like places where there was a lot of surface algae even.
Oh, so if you think that there is a temperature correlation, then does that mean that with climate change, we will expect increases in eutrophication kind of globally?
This is something I suspect. I didn't talk about this because I didn't find a consensus in the literature, but I suspect this is a problem. I think the biggest problem right now is eutrophication is already widespread globally. It's already a problem. It's, for example, that viral outbreak that happened in 2014, like I said. This can expose the problem dramatically if a lot of those viral outbreaks happen across the world, because those algae can just release toxins over. So the problem is already there, and then if those viral outbreaks happen, we actually see the problem in front of us. So I think that would be the biggest problem: more viral outbreaks that could be happening. But yes, climate change might be a problem.
Mm-hmm. Thank you. Does
Thank you
anybody
very
have
much.
any more general questions that could be asked to all of the panelists, or a question for either of our previous panelists, or a question for Jacques in particular? Now is a great time. You can raise your hand and speak your question, or you can put it in the Q&A as you wish. Otherwise, I'm going to keep asking questions because I always have lots of questions. So while I'm waiting to see if anybody was typing, I will maybe ask all of you to think about, well, I guess, Sahar, you've already discussed this, but maybe for Jacques and for Clara, what you think the implications of the pandemic might be, if any. I can see potential implications both for parks and maybe for eutrophication as well. So I'm wondering if you've had a chat. Obviously, these are not your research questions that you presented, but if you have any ideas or any thoughts about what those effects might be. Clara, maybe we can let you go first.
Sure. So I think I spoke to someone from Elk Island actually quite recently, and because they closed Elk Island from at the beginning of the pandemic, like in the summer, and so I did ask them, like, has that had an impact on the wildlife just in general, because like less people? And honestly, they said that they didn't notice that much of a change, and because they didn't like empirically actually kind of measure it, so they're not entirely sure, but they kind of, their assumption was that they did kind of hang around on, like, the bison and stuff hung around more on the roads. But because in Elk Island, this is like Elk Island specifically, they're not that used to humans really. Like they tend to keep their distance just because of the type of species that are in that park. So yeah, I just thought that was super interesting that even though they were closed for a couple of months, like apparently the wildlife didn't seem to have that much of a change at all, other than standing on roads more. So yeah, I wish I could know about what it would be like for the other parks, because yeah, Elk Island is kind of an interesting one because it's like the only fenced park and it's like one of the smallest. So yeah, I'm intrigued. I want to know.
Yeah, thank you. I've been to Elk Island and I remember not wanting to get out of the car. I don't even know if you're allowed, but bison are huge and frightening looking, right? So I can see that, you know, road traffic would maybe be the biggest effect for them. Yeah, the biggest change. Yeah. Jacques, what about you? Any thoughts?
It's hard to tell, but since there was a slowdown in the industries, this can be a main driver of the eutrophication because the industries release a lot of nutrients. It could slow it down. It could also, it's hard to say what could have made it increase with COVID. I can't really think of anything. Maybe if people say no, there's not really much that could make it go fast. I can only see a bit of positive since there's a slowdown in the economy, so less nutrient going to the water. It's the only thing I can see.
Right. Thank you, Jacques. I have
Thank
another
you.
question for you in the chat, which is, can you tell us about what you do now?
Oh yes. So I work for an environmental consulting company. So I'm not necessarily a consultant. So I work both in an office and on the field. So I do a lot of potable water research. I work in potable water. I also work on contamination. So I look for contamination or supervise decontamination projects. And right now I'm working mostly on potable water research, looking for potable water for municipalities, pretty much.
Thanks, that's super interesting. I was telling Jacques before we got on that you would maybe get that question. I always get that question. What do people do when they finish, when they graduate? So there you go. We don't seem to have any more questions. So if we're done with the conversation, then I will wrap it up and thank you all. Thank you to our panelists for giving great presentations and for sharing your research. Sahar and Clara, I look forward to seeing, you know, where you go with this. And what it looks like a year from now. And Jacques, I hope you continue in the area too. Super interesting work. And I hope to be able to keep up with all of you. Thank you to our audience for coming today. It's great to have you here and thank you for the conversation. And again to ForSpace for hosting us today. Do come back in 45 minutes. We have Angela Carter, actually at 3 o'clock in just under an hour. We have Angela Carter who will come and talk about the Keep It in the Ground movement and the policy implications of that. So that will be very interesting. Tomorrow morning, we have some life cycle assessment workshop and then a panel on life cycle assessment, which I encourage anyone and everyone to come to. We also have a careers panel tomorrow afternoon. So if you want to learn more about what people do in sustainability once they leave these ivory tower walls of academia, do come back. We have other events all week. So check out the website. I think Anna has probably put it in the chat because she's super efficient there. Otherwise, I will do it in a second. And thank you again for coming. Anna, I'll pass it along to you.
Thank you, Rebecca, Jacques, Clara, Sahar. It's been really great to hear about your research and to take this time to have a concentrated kind of mini deep dive into your worlds. We really appreciate you coming together in this way to share your work. And audience members, even though you're a little bit quiet here this afternoon, I understand it's St. Paddy's Day, it's sunny outside, you want to be out there. We appreciate you taking the time to come and join in the conversation. There were questions about the recording and yes, I've put the answer in the chat. So feel free to just look up ForSpace Concordia on YouTube and you'll find the recordings of most of these events, as well as in the link of the schedule that Rebecca has, the schedule of events for the week. The recordings are being pasted there as well. That was a really roundabout way of getting to my point. Anyhow, many options for finding these sessions. Thank you, everybody. On that note, obviously we're all getting a little loopy here and need a little break. We'll see you at 3 o'clock for the final talk of the day, hopefully. Okay, on that note, thanks, everybody. Bye-bye.
Thank you very much.
Thank you.